Okay. So again, just to kind of review or remind you what happened on day one, we just talked about the different types of transformations that were out there. Today's stuff, we're going to see more of the stretches and shrinks that are going to go on. So, first of all, Alexis, would you give me a parent to work with? One of the big four parents, not constant. I don't want to do constant. I want to do one of the other three. Would you give me one of the parents? Linear? Okay. So the problem's going to say f of x is equal to 1/2 x. Okay? So the directions, again, are going to be the same. It's going to say, graph the function on its parent, describe the transformation that takes place. Same exact directions, just this time we're going to have more stretches and shrinks. So, Alexis gave me that it was a linear. Is everybody okay with or comfortable with why that's linear? Okay, so first of all, when you're looking at this, it's not just a single number. Single number would be constant. Second, then you look at it, it's got an x. So then you look to see, does it have a squared on it? If it was squared, it would have been a quadratic. If it had absolute value bars, it would have been an absolute value. But since it doesn't, then that's why we know it's linear. The parent for that one, remember, was that diagonal line that went right like this. Okay? Or as some people like to refer to it as, it has a slope of 1. Remember slope a little bit? Up 1 over 1. Okay? Now, when you stretch and shrink stuff, it's like taking this rubber band that I have. I'm going to try to hold it up so everybody can see it. Okay, so if I have a rubber band and if I just hold it like this, like barely holding it, it looks kind of like an O, right? So if I vertically stretch it, vertically stretching it or vertically shrinking it, vertical would be up and down. What happens to the rubber band as I vertically stretch it?
Gets longer.
Gets longer, gets narrower, right? And what happens when I shrink it?
Gets fat.
Gets wider. Okay, and that's exactly what happens when we deal with vertical stretch and shrink. So now when I'm looking at this problem on this particular thing, the template, again, like I have up here on the board, is there a negative sign in front of my problem? No. Is there a number in front of my problem? Yes. Since that number is 1/2, what type of action is happening? Or a vertical shrink by 1/2. So that means that I'm going to push down or squish down so that my graph should not be necessarily diagonal, but it should be flatter. Okay? So like I made the analogy this morning in third hour, I said, it's like that bug that you stepped on this morning when you were coming to school. And now it's flat because you stepped on it. Right? Because you squished it. You shrunk it. So which way should my graph look? Should it look the same? Or should it look in a different spot? Should it still go through the origin? Yes, it should. The difference is now it's going to be a little bit flatter. And for those of you who are more comfortable with it, when we get to it, that's because the slope was 1/2, which remember rise over run stuff? Up 1 over 2, up 1 over 2. And that's kind of the basis or why I put it in that spot. All right? What do you guys think of the shrink? Okay? Now I'm going to switch it. I'm going to switch parents. And I'm going to give you f of x equals 5x squared. What parent did I give you for this one?
X squared.
X squared.
It's a nice parabola.
It's a parabola. It looks like a U. Okay, so as I draw it over here, draw something like that. Okay? Now for the blue one that's up there, when it says 5x squared, is the 5 inside or outside of grouping symbols?
Outside.
Outside, because there is none. If there would have been a grouping symbol, then we could say that it's inside, but since they're not, then we're outside. So, is there a negative sign on the outside? No. Is there a number on the outside? Yeah. What number is it?
5.
5. So is 5 a stretch or a shrink? It's a stretch.
Don't be good, real skinny.
Okay. So for that example, or that description, it would be a vertical stretch by 5. Now, as Eric was saying, it is going to get really skinny. And here's why. Some of you like the fact that when you graph things, you want to have ordered pairs. Okay, so think about the original parent. If I put 1 in for x squared, what's 1 squared? 1. So for the one that I have up here, it'd be over 1 up 1 and I have a dot. What's 2 squared? 4. So it'd be over 2 up 4, make a dot. Well, this is going to be a little bit different. If I put 1 in for this one, what's 1 squared?
1
Times 5.
5.
So instead of going over 1 up 1, it's going to be over 1 up 5, make dot. When I put a 2 in there, what's 2 squared? 4 times 5 is 20. So instead of going over 2 up 4, it's going to be over 2 up 20.
Oh, God.
So we are going to be stretched out. And that's why when I had a couple people ask me the question, you know, like, where should I put the graphs? How technical should I be? It's tough to graph 20 on the little graphs that you guys have, right? So as long as you're in the right ballpark, I'm giving it to you. So for this particular thing, it would be something like that. It'd be stretched out or on the inside of the original one. Okay, does that make sense? So shrinking is going to make it wider. Stretching it is going to make it narrower for the vertical part. Ms. Burkhardt.
May I use this one?
Sure. Now, the next type, same directions. It's going to be sketch the graph and its parent. Actually, let me back that up. The directions for this one actually says this. Use a graphing calculator to sketch the graph and its parent and then describe the transformations that take place. Now, one thing that I realized for you guys is not a whole lot of you have your graphing calculators yet. Okay? That's what I meant by you got to get them as soon as possible. So as far as using a graphing calculator right now, we're going to table that until we start getting the majority of you here that have them. But I'm still going to do the same type of directions. Describing what happens, sketching both of them. So, what's the parent?
It's the absolute value.
And how'd you know?
Because there's absolute value.
Right.
It makes it V.
Okay, so the absolute value is a V. Now, as far as the transformations that take place, is there a negative in front? Yes. That means we have a reflection over the x-axis. So we do have a reflection over the x-axis. Is there a number in front? No.
1.
Besides 1. Is there grouping symbols? Yes. So now if I look inside the grouping symbols, is there a negative in front of the x? On the inside. Is there a number on the front and the inside in front of the x? No. Is there a plus or a minus on the inside after the x? What does a minus 3 tell you? We're going to go right 3. Is there a number added or subtracted on the outside? No. So when I draw this next one, what I'm going to do is I'm going to take the original one that's on there, and I'm going to do the things that you guys told me to do. I'm going to reflect it over the x. So instead of opening up, it should open down. And I'm also going to move it to the right 3 spaces. So 1, 2, 3. And you guys told me it should open down instead of up. So yes, I could have used a graphing calculator to get that, and if I brought mine up, I would show you that I'm pretty close or I'm in the right spot. The second part of it is going to give you more than one transformation to do on a certain part. Okay, that's what the difference is going to be. Okay? I'll give you another one. Okay, so for this one, what I want you guys to do, talk about it in your groups as far as what transformations take place. So take 30 seconds now and talk to each other what transformation took place, or which transformation took place.
There's definitely a shift left.
I just think it's good. I don't know why she's based here like that.
Okay, so with that, first of all, Miss Birdall, what is the parent? I didn't ask that question, but I just want to see if you know it. What's the parent? So I know what to draw first.
Quadratic.
Quadratic. Good. How'd you know? It's Haley, right?
Yes.
Haley, how'd you know?
Because it's square.
Good. That's it. That's all you have to know is that it's squared. Nice job. Logan, what was one of the transformations that you guys talked about? Shift right?
Yeah.
Okay. Anybody else get shift right?
No.
No.
No? Okay, now here's where a lot of people get this backwards. When it's an adding on the inside, I know adding you would think that it goes to the right, like that's positive on a set of axes, but this actually is backwards or opposite of what you'd think. So on the inside, if it's adding, we should go left. Okay, so we're going to go left. How far does it go left? 3. Emily, was there any other ones that happened? Down. How far?
2.
Down 2. Okay. So again, we have 2 different transformations. According to what you guys told me, you told me to go left 3, so 1, 2, 3, and you told me to go down 1, 2. Does it still open upwards?
Yes.
I didn't reflect it, did I? No. So all it did was it just changed locations, but it still should go upwards. Okay? What do you think? Okay, when you look at the directions for this stuff, again, it says the same type of things. Now, the only directions that I am going to change, and the last 2 that are the last 39 and 42, it might say identify the function and family, describe the domain and the range. I haven't talked about domain and range yet. I just want you to describe the family for now. So what that means is I just want you to tell me what parent it belongs to. Okay? That's all I want you to do for that part. So even on the computer, and if you answer it on the computer and it asks you what family, and then after that it says domain and range, just leave the domain and range part blank. Okay? You might not get 100%. It's okay. Because honestly, I'm not even necessarily looking at that part. Okay? But on that particular, those 2 questions, 39 and 42, I just want you to answer me what family it's from. Alright? What do you guys think of this? Does having that thing up there help?
Yeah.
Okay, good. Then it'll stay. Sure, absolutely. So on page 9 and 10, we're 21 to 42, multiples of 3, 46 and 51.
21 through what? Oh, never mind.
It's on there, Donna.